Hey YouTube, thanks for visiting. Hope all you are doing well, and I'm very sorry that I make this video after a very long period of time because of I was actually a little bit busy. So I already make two videos. I have already made two videos on West Bengal set uh, 2025, the solution series, and I think in first video we have covered the complex analysis and linear algebra, and I think one questions or two questions from Boolean algebra in this first video, and in the second video we have covered the ODE and PDE and integral equation and calculus of variation. So we make these two video or lecture 1, lecture 2. So in today's video we will cover actually seven questions that comes from classical mechanics, and number two, I think this question comes actually from continuum mechanics. Continuum mechanics, one questions from, and two questions. I think there are from two question, and the other is numerical analysis. There are three questions. So in today's a very short lecture, and we will cover the seven questions. The first question is this one. It says the Hamiltonian of the dynamical system is given by H PQ or QP equal to this. H QP is equal to QP minus Q square. Fine. So what is the four option has given? So here we actually first find the Hamiltonian equation. What is the formula of Hamiltonian equation? Hamiltonian equations are given by Q dot equal to del H del P and P dot is equal to minus del H del Q. So these are the two equations of Hamiltonian. Fine, Hamilton's equation. Del H del P means, from here we can find that del H del P means simply Q, and the del H del Q means what? P minus 2Q. A simple derivative of this function actually. So now we have to solve these two equations. So Q dot is equal to Q means, from this Q dot equal to Q, what is the solution of Q dot equal to Q? This is a very easy OD, and Q dot means what? dq dt equal to Q. So the solution is like that. Q is equal to, suppose, A e to the power t. This is the simple solution of this equation. And now P dot equal to, that is dp dt is equal to dp dp plus P. This is equal to 2Q, and 2Q means 2A e to the power t. So this is the very standard form of first order differential equation. Vp dt plus P equal to Q, and here the integrating factor we need, that is equal to e to the power t. Now if we multiply it by integrating factor and solve this equation, this is P e to the power t integration d of P e to the power t. This is equal to integration 2A e to the power 2t dt, multiplying the integrating factor both side and integrating, right? So we get P e to the power t is equal to 2A into 2, I think, 2A into e to the power, no, I think e to the power 2 e to the power 2t. So e to the power 2t by 2. That means A e to the power 2t plus, suppose, B. So this implies simple P equal to A e to the power t plus B e to the power minus of t. So these are the two solutions. Now for this case, if t tends to infinity, obviously e to the power t exponential t tends to infinity, that means q tends to infinity. This is one solution, and in this case, what we get from here, that at t tends to infinity, the first term, that is this one, goes to infinity, and the second term goes to 0. That means actually infinity. So both the p and q goes to infinity. That means what is the correct answer? The correct answer is option A. P tends to infinity and q tends to infinity. Next question, this one. It says that if q1 and q2 are generalized coordinate and p1, p2 are the corresponding generalized momenta, then Poisson bracket pq between p and q, where p equal to this, q equal to this, is given by. So Poisson bracket, what is the definition of Poisson bracket? PQ is equal to summation over I, what, del P del QI into del Q del PI minus del P del PI into del Q del QI. So this is the definition of Poisson bracket. Fine. Now we have to find these derivatives from here. So what is P? P is given by, just a second, P is equal to Q1 square plus Q2 square. Now del P del Q1, this is equal to 2Q1, and del P del Q2, this is equal to 2Q2. And since PI is, with respect to QI and PI, and these derivatives actually 0, because P is PI, small pi is not present in P, that is P is excluded of generalized momentum. That means del P del Pi for I equal to 1 and 2 is equal to 0. Fine. Now Q is equal to given by 2P1 plus P2. That means del Q del P1 is equal to 2 and del Q del P2 is equal to 1, simple. And the other cases, del Q del Qi, this is equal to 0 for both I and I equal to 1 and 2, because Q is independent of Q. Capital Q is independent of the generalized coordinate small q. That means simply here 1 and 1 and 2 and 2. Okay, 1 1 and 2 2 will be the answer, because this is over summation. That means for this case, P and Q is equal to del P del Q1. Del P del Q1 means 2Q1, and del P del Q del P1. Del Q del P1 means this one 2 minus for I equal to 1. This is for I equal to 1. We write this for I equal to 1. So then is del P del P1. Del P del P1 is 0. Yes, this term is 0. That means no negative term. And del Q del Qi is also 0. So this is for first term is 0 for I equal to 1. This is for I equal to 1. Only this part have. Okay. Then plus, then for I equal to 2. For I equal to 2 means del P del Q2. Del P del Q2 means 2 Q2, fine, into del Q del P2. Del Q P2 means 1. And minus the term is, minus term is, this is not working. What is the minus most term? Then for del P del Q2, there are no, yes, del P del Q2, and this term del P del P2. P2 terms is not present, so this is 0 actually. So that means 4Q1 plus 2Q2. This is the answer. Option number B. Okay. This is a very nice question. This is the answer. Next question. So these questions is actually from classical mechanics. Yeah. So it says that a bead of slides without any friction on a frictionless wire in a shape of a cycloid. X is equal to this, y equal to this. If g is the acceleration due to gravity, then Lagrangian function is given by. So the general formula for find the Lagrangian is equal to L equal to T minus V. Okay, and what are the T and V? T is the kinetic energy, that is kinetic energy minus potential energy, Ke minus Pe, the most general formula. Fine. So now we have to find this T and V. So T means C. What is the expression of T? T means half mv square, and V means just a second. V means formula is mgh. Now we first have to find this V. So V equal to what? Because here x and theta are given in x dot. mm, what are the term in velocity or in x direction and y direction? X dot, that means dx dt, and dx dt means we can write here because x is dependent on theta, so dx d theta into theta dot means d theta dt, and y dot is equal to what? dy d theta into theta dot, and v square equal to, simply we can write that x dot square plus y dot square. So from this expression we actually get this v square. So now we have to find this dx d theta and dy d theta. So dx d theta from the given equation equal to a into 1 minus cos theta, and dy d theta is a into minus a sin theta, right? So now x dot square plus y dot square equal to x dot square plus y dot square. This is equal to a square into 1 minus cos theta, sorry, 1 minus cos theta whole square into theta dot square plus a square sin square theta into theta dot square. So if we take common a square theta dot square, then it will be like 1 plus cos square theta minus 2 cos theta plus sin square theta. And we know that sin square theta plus cos square theta equal to 1. That this actually comes 2a square theta dot square into 1 minus cos theta. So this is the value of x dot square and y dot square. So what is the value of t? So t equal to half m, cancel from here. So m a square theta dot square into 1 minus cos theta. This is the t. And what is v? Simply v equal to m g. H means what? H means the height, and since this is a this is an xy plane, so that means y gives our height. So mgh, h means y, the value of y is a into 1 plus cos theta. So this is v. Therefore L equal to what? L equal to m t minus b, a square theta dot square 1 minus cos theta minus mga 1 plus cos theta. Which option is gives our answer? Option 1 minus, yes, this B. Fine. So this is the answer of this question. Next question, this one. This question says that a continuum body of extension, this is actually a question from solid mechanics. Body of extension of a line element through the center of the strain quadric in the direction of the radius vector is equal to. So we have to assume some things. So that radius vector, first we assume that radius vector is equal to r, suppose r is vector, and and the direction cosines dc are, suppose ei. Ei are the direction cosines of this body actually. So the normal strain is given by normal strain. Normal strain is given by, this is a formula, standard formula, okay, given by epsilon capital is equal to epsilon ij xi xj, and xi and xj are the different directions, okay. Now for for strain quadratic that is given here. Quadratic in the direction of radius vector. Okay, the radius vector satisfied what? Epsilon ij xi xj, this is equal to 1. And what are the these xi and xj? Since r is the radius vector, so if small r is the magnitude of that radius vector, then we can write xi equal to magnitude into the dci, and yxj equal to similarly r ej. Fine. So now we put this value to here in this equation. So we get actually epsilon capital, this is equal to epsilon ij into, in this equation, equal to 1. In this equation, what we get? Epsilon into r ei into r ej, this is equal to 1. That means what? R square, sorry, I think is in EIEJ. So R square epsilon ij EIEJ means 1 into epsilon. R square epsilon, this is equal to 1. I think, no, this one xi. This will be xi only. That is xi, okay. This is equal to 1. So that means this is equal to 1 by r square. This is actually the standard result, but you can show like in this way. That means the inverse square of the radius vector. Option A. Okay. This is actually very standard statement. Okay. This is actually very standard statement, but you can show like this way. Next question. This is from numerical analysis. Which of the following method is best as far as the accuracy concerned for the initial value problem? So we start with the Euler's method. We know that Euler method, order of the Euler method equal to 1, order of the modified order equal to 2, this is of order 4, and Taylor series that we can use actually as we can for like order 1, like order 2, like order 3, like this. But as we know that in Taylor series, uh, as compared to these three process, Euler series, Euler method, and modified Euler method, Rankutta method of order 4 is far better than these three methods, and in this process actually the temporal error value is very less. This is very standard questions, very easy questions actually. So these three we can easily discard, and option D is the answer. Okay, from these three method, if we compare these four method, then Rankutta method, that is RK method of order 4, it gives the more accurate result for initial value problem in numerical analysis. Now question number 11. It says that if delta, forward delta, backward delta, shift operator, and the finite central difference operator respectively, which of the following statement are true? So first we define these four result. Capital delta fx is equal to f of x plus h minus fx. Backward delta fx, fx minus f of x minus h. Then e of fx, this is equal to actually f of x plus h, shift operator, and delta fx, this is equal to f of x plus h by 2 minus f of x minus h by 2. H is the step function, step of the step size actually. So this, and also there is a relationship between delta and shift operator. So delta is isoform equivalent to shift operator minus identity. Backward delta is equal to identity minus inverse shift operator. This is E, and this is delta is equivalent to E of half minus E of minus half. So this will be very necessary to solve this problem here. So what is backward delta? Backward delta means 2 delta e to the power half. So if we write for option 1, for example, for option A, right? So if we calculate the right side, 2 delta e to the power minus half, this is equal to delta means e to the power half minus e to the power minus half into e to the power minus half. This is equal to 2 e to the power half into e to the power minus half is I minus e to the power minus of 1. But this is not equal to E inverse. This is correct, right? This is equal to 2 into backward delta. 2 into backward delta, okay. 2 into backward delta. But here it is only delta is given. So option A is not correct. Option A is not correct. If here 2 is given, then this will be true. But in this case, is not true. Option B. Delta square E square equal to delta square. So delta square means E of half minus E of minus half whole square into E square. This is we calculate first. This is E plus E inverse minus 2 E to the power half e to the power minus half into E square. This is actually E plus E inverse minus 2I, that means identity operator, into E square. This is equal to E cube plus E 2 minus 1, hence E minus 2 E square. But this is not equal to delta square. If we calculate delta square, then E minus I whole square is equal to E square plus I square means I minus 2E. No, these two are not equal. That means this option is also false. Option C. Now we check option C. Delta minus delta equal to delta square. So delta square means we have already calculated this term. Okay. So now we see the forward delta minus backward delta. Forward delta minus backward delta. This is equal to E minus I plus E inverse. This is equal to E plus E inverse minus 2I. Yes, this is exactly this term. So this term and this term correct. That means option C is our correct option. So we don't need to forget, or do we need to check option B. Okay. Next question. This is a very easy and straightforward question. If the points x1, x2, xn are distinct, then for arbitrary real values of y1, y2, yn, the degree that the interpolating polynomial Px such that Pxi equal to yi is, what is the degree we have to find. So this is a very basic question. Remember this statement: for any n number of points, any n number of points, there exists a unique polynomial, suppose Px, of degree at most n minus 1. This is n, okay, n minus 1, degree at most n minus 1, degree at most n minus 1. That means the degree obviously less equal to n minus 1. This is correct option, option C. A very basic question, okay, of numerical analysis. So these are the questions for today. This is the questions for today's lecture. If this video is helpful for you, then please give a like to this video, share with your friends, and don't forget to subscribe the channel. Thank you. Let's meet in another video.